if we substitute this into this equation, we'll have V divided by lambda n, but lambda n is this. So n times 2L. So n V on 2L. So that when we substitute V, which is this, we'll have Fn being equal to n over 2L times T on mu. So there are a lot of ways to go around this. So this is the expression for the nth harmonic. Then we also saw yesterday that for vibration in strings, the frequencies or the harmonics are a mixture of even and odd. So F1 is equal to V on 2L. F2, this we saw to be equal to 2V on 2L. F3, 3V on 2L. So basically, we saw that this is F1, and the second harmonic is 2 times F1. The third harmonic is 3 times F1. So the coefficient is 1:2:3:4, on and on. So the harmonics or the frequencies for vibration in strings are odd and even harmonics. Okay, where this is the first harmonic, second, third, and so on and so forth. So the nth frequency or nth harmonic Fn is equal to n times F1 or n times V on 2L or n divided by 2L times T on mu. Okay. Then we also observe that for the nodes or the loops or the stationary waves, there is a portion where the string must be plugged to give you a certain harmonic. And this relationship is given by blocking distance from one end, blocking distance is given by length of the string divided by 2 times n or p, where n represents is equal to a number of loops. Meaning that when a string vibrates and the loop formed is just 1, n is equal to 1, which in drawing n is equal to 1 has this shape. Just the first harmonic. Then the blocking distance from one end of the string must be equal to L over 2 times 1, which is half the length. What it means is that to give this node or stationary wave or loop, we must block the string at the midpoint of it, half the length. Okay, so you hold it and then plug it at this distance and you have this node. Okay. Now, harmonics F1, F2, F3, F4, on and on are also termed as overtones. So we have harmonics, and overtones, What is the difference between harmonics and overtones? So usually in exams or problem solving, instead of harmonics, it can be said as overtones. Now, the difference between harmonics and overtones here is that in harmonics, we count from the fundamental frequency or fundamental harmonic. So in harmonics, we have F1, the next F2, F3, and the nth harmonic Fn. So these are in harmonics. In overtones, it's the same frequencies, but in overtones, we don't.
But then Elvina is not in the class.
Nathania or Samuela, please mute yourself, okay? In overtones, we disregard the fundamental frequency. We don't count it. Okay, so if the nth harmonic is given by n times F1. In overtones, we don't regard the first one. So the second harmonic is the first overtone. The third harmonic becomes the second overtone. The fourth harmonic becomes the third overtone. So the nth overtone is given by n plus 1 of F1. So in overtones, we do not count the first fundamental frequency. So F2 is the first overtone, second overtone, F3. So the nth overtone is given by n plus 1 of F1, whereas the nth harmonic is given by n times F1. Please, have you noticed the difference between harmonics and overtones? Is that point clear? Class, so take note. So usually, as we will apply this in survey questions, instead of harmonics, we'll talk about overtones. So we see how you can switch from overtones and harmonics. Okay, I earlier posted 3 trial questions. I earlier posted 3 trial questions, which was dubbed the work set. I have Vestus.
So please, what are overtones?
You see, the overtones are no different from harmonics. Okay. You see, we define the harmonics as a set of frequencies which represents the integral multiple of the fundamental frequency. A set of frequencies which represents the integral multiple of the fundamental frequency. What do we mean by integral multiple? So you see, F1 is F1, F2 is 2 times F1, F3 is 3 times F1. So you are saying these are the harmonics. They represent a set of frequencies which represent the integral multiple, a number multiple of the fundamental F1 frequencies. And these are what we call as harmonics. Now with overtones, the same harmonics. The only difference, Festus, here is that in overtones, we disregard the fundamental, we don't count the fundamental frequency. So it's like the fundamental frequency is like 0 overtone. Meanwhile, F2 becomes the first overtone. F3 becomes the second overtone. F4 becomes the third overtone. So basically, in overtones, we do not count we do not look at the fundamental one. Festus, are you okay?
Yes.
So that's just the difference. So in overtones, the end for harmonics, the nth harmonic is n times f1. In overtones, the nth overtone is given by n plus 1 of f1. So it means that for the first overtone, where n is equal to 1, f1 will be equal to 2 times f1. Okay, f2 will be equal to 3 times f1. So we are only ignoring the f1 but. So first, please, are you okay? That's what we mean by overtones. All right, so today's next one. Okay. It's here. Please, I've sent it to the group, so check for me. A 1.0 centimeter long string. A 1.0 centimeter long string vibrates with a fundamental frequency of 256. Ooh. Okay, so a 1.0 centimeter long string vibrates with a fundamental frequency of 256 Hz. If the length is reduced to 1/4, if the length is reduced to 1/4 centimeter, if the length is reduced to 1/4 centimeter, keeping the tension unaltered or unchanged, the new fundamental frequency will be, okay, so the length of the string is 1 centimeter. The fundamental frequency is 256. Then if this length is reduced to 1/4 centimeter and the tension in the string is kept constant, what will be the new fundamental frequency? So I'm giving you 3 minutes to see what you can do. So we look at the other set of questions. So start work. The question is on the platform. Let's see what you can produce in about 3-5 minutes time. I didn't